Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from March 2023, paper 1-2 for Cambridge AS Physics. In this lesson, as always we do, we will discuss these questions in detail so you can improve your conceptual understanding of AS Physics and also you can have better understanding of these questions. Let's study together, let's improve together. In today's class, we are talking about March 2023, paper 1-2, and total time for this exam is 1 hour and 15 minutes, and there are 40 questions on this paper and you need to answer all of them, and the total mark for this paper is 40. If you go to the second page, on the second page you can see values of some important constants. If you need value of any constant for some calculations in your exam, you can come to this page and you can find values of constants. On same page you can also find some basic formulae, and if you have forgotten any formula and you need formula for calculations, you can also come to second page of your exam paper and you can find some basic and important formula. Question number 1 says, what represents a physical quantity? So simply we need to understand what is a physical quantity. A physical quantity should have magnitude. We can simply write down a physical quantity should have magnitude and it should have unit. Magnitude and unit. So if you look at this given options, A is not possible because it has no unit, and B is just a unit, it has no magnitude, and 7.0 Newton, this has magnitude and unit. So the answer for this question is C. D is also not answer because it's just percentage, so D is also not answer. So the answer for this question is C. So you need to understand a physical quantity should have magnitude and also it should have unit. So for this question, answer is C. Question number 2 says the relationship between the variables d and t is given by the equation, by this equation. It is also given to us that b and c are constants and the unit of t is given, that is meter square, and unit of t is second. We need to find out what are the units of b and c. This is a typical question about homogeneous equation. For homogeneous equation, we need to understand each term should have the same unit, and we will be using this concept and we will answer this problem. So we can write down units first of all. The unit of 1 over t is per second, means 1 over second, and we can write down b, and the unit of d is meter square, so we can write down meter square, and there is square root of this one, and here we have c. So this is homogeneous equation, so simply we can say this is per second, then here we have b, so here we will have meter because the power will be cancelled, and the unit of c has to be per second because each term should have the same unit. Now we need to find out unit of b, so we can write down per second. Here we have meter here, so we have to cancel meter, so we should have meter here, and also we have unit, we should have unit per second for this term as well, so we should have per second in numerator, and it is divided by m, so here we have this is per second, so this is the unit of c. Now simply from here you can see this is the unit of b, b has this unit and c has this unit. If you further you want to write down, you can write down this is per second, so meter will be cancelled, so this will be per second, so each term should have the same unit. You can also understand this one with the help of V. This is equal to U plus AT, because sometimes students are not very clear about this one. Always we do the same thing. For homogeneous equation, the unit of V is meter per second. Unit of U is also meter per second. Unit of A is meter per second, meters per second. Unit of time is second. So you can also see from here, each term has the same unit because this is homogeneous equation. Each term should have the same unit. So this is unit of B and this is unit of C. So the answer is not possible. B is right because this is unit of B and this is unit of C. And C is not possible because this is wrong. This is also incorrect. This is incorrect, but this one is correct. And so the answer for this question is B. This is how you can figure out. Question number 3 says a hollow cylinder which is open at both ends has a radius of 3.0 plus minus 0.1 centimeters and a length of 15.0 plus minus 0.1 centimeters. What is the value with its absolute uncertainty of the surface area of the cylinder? We need to calculate surface area of the cylinder, but this is very important one, that this cylinder is open at both ends. Very important point you have to consider when you need to calculate surface area. If cylinder was closed at both ends, surface area will be greater as compared with when cylinder is open at both ends. So in this case, it is given to us, it is open at both ends. So we can simply draw a beautiful cylinder. So this one is a cylinder and it is open at both ends. So this is the cylinder. We can also imagine in this case, the radius of the cylinder is capital R, and we can imagine the length of this cylinder, let's say, is equal to capital L. Now we need to calculate surface area. Surface area simply will be equal to 2 pi r, means you will calculate circumference of this circle and you will add all of them for L time. Simply multiply with L. So this is how we can calculate surface area. Now simply we need to plug in values. We have 2 pi and r is given to us, that is equal to 3.0 centimeters, and L is given, that is equal to 15.0 centimeters. Now if we multiply this one, we will get 282.78 centimeter square. So this is value of surface area. Now we need to calculate absolute uncertainty of surface area. So we have delta S divided by S, and this one has to be equal to delta R by R plus delta L by L, because these constants, when quantities are multiplied and divided, they have no role in percentage uncertainty because they will be cancelled. So they have no role in percentage uncertainty. So that's the reason simply we ignore them. So in this case, we can say delta S, this is equal to delta R by capital R, plus we have this is delta L by L multiplied by S. Now simply we need to plug in values. Delta R is equal to 0.1 and R is equal to 3.0, plus we have 0.1 divided by 15.0 multiplied by S. S is equal to 282.78. Now if we solve this one, we will get delta S is equal to 11.3 centimeters square. So this is the absolute uncertainty in surface area. So this is delta S. So we can rewrite here. Delta S in this case is equal to 11.3 centimeters square, and we have calculated value of S. This is value of S. Now we need to write down S plus minus delta S in this form, in surface area with its absolute uncertainty. Now this part is little bit tricky one. You need to understand is that, so here we will have value of S plus minus, we will have absolute uncertainty. Absolute uncertainty, you have to write down up to 1 SF only at AS level. So up to 1 SF, how we can write down this one? Up to 1 SF, we can write down this one is 10. Now this one has, so one thing you need to understand, it should have 1 SF only. You have to follow this rule at AS level, 1 SF. Now the number of dp here, so the second thing, let me use different color, absolute uncertainty and the measurement here, they should have the same number of decimal places. So it means that S should not have any decimal. This is 282.78, so we can write down this one 280. So now this has no number of decimal places, and this also has no decimal places. This has 1 SF and this one has 2 SF. If you look at raw data, this has 2 SF. So it also satisfies this condition, least number of SF in this measurement. So the answer for this question has to be A. So 2 points you need to understand. Same number of dp. First of all, you have to write down absolute uncertainty up to 1 SF only. Then absolute uncertainty and this measurement, they should have the same number of dp. Same dp. So this rule you have to follow. So the answer for this question is A. slowly. Question number 4 says a snooker ball of mass 0.20 kgs has a collision so that its direction of movement changes by an angle of 90 degrees, as shown in the figure. The ball has a speed of 0.40 meters per second before the collision and a speed of 0.30 meters per second after the collision. We need to find out what is the magnitude of the change in momentum of the snooker ball. So if you get this ball, it has initial momentum. We can simply write down that is the I, and that is equal to mass of the ball 0.20 times the speed of the ball. So this is the initial momentum, and also we can write down the final momentum for this ball. Mass of the ball is 0.20 and the speed of the ball is 0.30. We need to calculate for this question delta P, and delta P will be equal to P final, means this vector, minus P initial momentum, and this is equal to the change in momentum. We can also write down this one in a little bit different form. We can say P final plus we have negative Pi, so this is P initial. Now simply we need to add these two vectors together and we can find out delta P. So in this case we have, first of all, this one is P final and this one is P initial, but negative of P initial. So this is to the right, so the negative Pi will be to the left. So this is Pi. And this one is P initial, so you can say this is negative Pi. And we have P final, this is vertically up, so this one is P final. So we can also label this one, this is P final vector. Now we need to find out sum of these two vectors, so simply we need to add. So the sum of these two vectors is equal to this one, and this is delta P. This is delta P. Now we need to find the sum of these two vectors, and the sum of these two vectors is equal to delta P. So we can simply write down delta P because this is a right angle triangle. So simply you can say delta P in this case will be equal to, we are just interested in magnitude. So this is the magnitude. This will be equal to P final square, means the magnitude of P final square, plus magnitude of P initial square, and we have to take the root of this. Now if we plug in values for P final, we have this is 0.2 times 0.30 square of this one, plus we have 0.20 multiplied by 0.4, this is 0.40. We have to take square of this, and then we take, if we take the square root, our final answer will be equal to 0.10 kgs meter per second. So this is the change in momentum, magnitude of change in momentum, and change of momentum has to be along this line. So this is how we can figure out. So this is, and also the force is along change in momentum. So the force has to be applied in this direction. So this is also direction of resultant force acting on this ball. So the answer for this question is B. Very nice question. So this is how you can figure out. Question number 5 says a ball is kicked upwards at an angle of 45 degrees to the horizontal ground. After a short flight, the ball returns to the ground. It may be assumed that air resistance is negligible. What is never zero during the flight of the ball? So the best way to answer this question is simply we can sketch. So the ball is fired at an angle of 45 degrees. So this angle is about 45 degrees. So this is 45 degrees. So the ball will go first of all up, then this ball will come down. So this is, you can imagine the trajectory of the ball. Now we need to look at first of all acceleration. Acceleration along vertical is equal to g, and direction of acceleration along vertical is always vertically downwards. And if you look at acceleration along x, this one is equal to 0 because there is no force along horizontal. And if you look at horizontal component of velocity, this will always stay constant throughout this journey. So we can say ux is constant because there is no net force acting along horizontal. So ux at this point has also the same value as it has at this point, means the initial value. So if the velocity is v, so the ux will be equal to v. You can say this is also u, so this will be equal to u cosine of 45 degrees, and the magnitude at the peak also will be equal to u cosine of 45 degrees because magnitude will not change, and direction also it will stay the same. But vertical component of the velocity, this will keep on changing. So this will not be constant. So simply we can say Vy will not be constant. But at this point, Vy, this one will be equal to 0. This will be equal to 0. Question is asking you what is never 0 during the flight of the ball. So in this case, if you look at horizontal component of the ball acceleration, this is 0. This is 0. So it means this one is not possible answer. Horizontal component of the ball velocity never 0. Yes, this is true because this is never 0. It always stay constant. The vertical component of the ball momentum, this will be 0 at the top because V will be 0. So this is also not correct answer. The vertical component of the ball velocity, also 0. So this is also not possible answer. So the answer for this question is B. This is very nice question. You need to understand these basic points about projectile motion. Question number 6 says the graph shows the variation with time t of the displacement s of an object. Which graph represents the variation with time t of the acceleration a of the object? So we have ST graph. So first thing we need to understand what is gradient of ST graph representing. So we can write on gradient of ST graph is representing velocity, or you can say speed, because we are just talking about magnitude. Now if you look at the first part, we can say this is first region, we can say this is the second, and we can say this is third, and we can say this one is the fourth. So you can see in first region, it means from this point to this point, velocity is constant. So there is no change in velocity, and this gradient is positive, so the velocity is positive here. Gradient of this part is negative, so velocity is negative here. Gradient of this part is positive, so velocity is positive and constant. Gradient of this part is negative, so it means velocity is also negative. So it means acceleration from here to here, it will be 0. But if you look at this one, when the velocity change from positive to negative, so there is a change in velocity. So there will be acceleration. Positive to negative, it means there will be negative acceleration. And if you look at this one, velocity change from negative means for a very short period of time. Velocity change from negative to positive. So there is a positive acceleration here. So we can say here acceleration will be negative. At this very short period of time, there is a change in velocity. Acceleration will be positive, and here velocity change from positive to negative, so there will be acceleration that is negative. So we have acceleration at this peak, at this peak, at this one, and rest of the time acceleration is equal to 0. So the answer for this question is D, and this is how you can answer. Let me explain you one more point. Delta V, if this is equal to 0, it means A is equal to 0. So in this case, you can see the final velocity is negative. So if we write down A, this is equal to delta V by delta T for a very short period of time. So this velocity is negative minus negative divided by delta T. So in this case, we will get negative. So this will be negative 2v divided by delta T. So acceleration is negative here. Here will be positive, here will be negative. So the answer for this question is D. Little bit tricky question, but if your concept is clear, you can find out. On other hand, this is a nice question to develop your understanding of ST graph, VT graph, and AT graph. Question number 7 says, which expression defines force? So for force, we have to be very clear that when we define force, this is equal to delta P by delta T. So simply it means change in momentum over time taken. So we can say force is equal to change in momentum over time taken. And this force is the resultant force. Change in momentum over time taken. So we can write down here, this is over time taken. Change in momentum over time taken. So very important and basic concept about force you need to understand. Actually, this force is representing the resultant force. So answer in this case has to be equal to D. Every year, in every paper, there will be one question about F is equal to delta P by delta T. Sometimes you need to calculate, sometimes you need to define force. So you have to be very clear about this one and how to use this equation. Question number 8 says, a ship of mass 8.4 times 10 to 7 kgs is approaching a harbor with a speed of 16.4 meters per second. By using reverse thrust, it can maintain a constant total stopping force of 920,000 newtons. we need to find out how long will it take to stop the ship. So you can simply imagine this is the ship. So this is ship. And also we can imagine ship is moving to the right and the initial speed of the ship is given, that is equal to 16.4 meters per second. We can also imagine there is an opposing force that is trying to stop this ship. So this is the opposing force. So F in this case is given, this is equal to 920,000 Newton, and finally this ship stops somewhere here. So the final velocity will be equal to 0. Question is asking us how long it will take, means the time taken between these two positions. So simply we can say time taken is delta t. So the best way to answer this question is simply we can write down resultant force in this case will be equal to change in momentum over time taken, and in this case we will take to the right is positive, and we need to calculate in this case delta t. So we can rearrange delta t will be equal to delta p divided by f. Delta p, so m times v minus u over f. So we have value of mass. In this case, mass is given to us, that is equal to 8.4 times 10 to 7, and v is equal to 0, and u in this case, u is to the right, so this is positive, and value of u is 16.4. But force in this case is negative because force is acting to the left, so this is negative, so we have to use negative sign here. So this is negative. Now if we simply solve this one, our final answer will be equal to 25 minutes. So this is the final answer. Up to 2SF, you will get 25 minutes. So this is the time taken to stop this ship. So the answer for this question is C. Question number 9 says the velocity time graphs of 4 different objects are shown. Which graph represents an object falling from rest through a long distance in Earth's atmosphere? So it simply means that ball started from rest and we cannot ignore air resistance. So simply we can imagine we have a ball and the initial velocity of this ball is equal to 0, and in this case air resistance is not negligible because there is Earth atmosphere. So these dots, they are representing atmosphere. So in this case, as the ball will start falling, there will be force acting on the ball in upward direction. This one is air resistance. And the force acting downwards, this is gravity, and gravity will remain constant in this case because gravity does not depend on speed. But air resistance depends on speed, so air resistance will increase. So initially we can say acceleration will be equal to g because acceleration is due to force of gravity, but when ball is moving, acceleration will decrease because F net will decrease. And finally, these two forces, they will balance each other. So air resistance is acting upwards and the magnitude of air resistance will be equal to magnitude of gravity. When these two forces are balanced, acceleration of this ball will be equal to 0. And so at this instant of time, ball has reached terminal velocity. We also need to understand one more point, then we can answer this question. Gradient of VT graph, you also need to understand gradient of VT graph, this is equal to acceleration. So we can say this is equal to acceleration. Now if you look at given options, if you look at initial velocity, it has 0, so it can be possible answer. This one also can be possible answer. This also can be possible answer, but this is not possible answer because initial velocity is not 0. Now we need to understand as the ball is falling down, speed of the ball is increasing, but acceleration of the ball is decreasing. It means the gradient of the line has to decrease. So if you look at this gradient is constant. So this is telling us that there is no air resistance because A is constant in this case. So A is constant. So we can also write down in this case A is constant. So this is not possible answer. And if you look at this one, the gradient is increasing. So the gradient of this one is increasing. So this is telling us that acceleration is increasing with time, but acceleration is decreasing with time. So this is also not possible answer. Now if you look at this one, gradient is decreasing with time, so it means acceleration is decreasing with time, and finally ball has reached terminal velocity, so acceleration is 0 because the gradient of this line is equal to 0. So it means answer for this question is D. This question is telling us that acceleration is equal to 0. Because the gradient of line is 0, it means acceleration is 0. It means ball is falling with constant velocity. So the answer for this question is D. This is also a typical question. You need to understand these concepts, how to approach this type of problems. Question number 10 says, which statement about collisions is correct? If you look at option A, it is given to us kinetic energy is conserved in all collisions. And this one is incorrect because kinetic energy is only conserved in perfectly elastic collision. Only in perfectly elastic collision. So option A is incorrect. If you look at option B, it is given to us momentum is only conserved in perfectly elastic collision. This is also incorrect because momentum is conserved in elastic and also in inelastic collisions. In inelastic collisions. So option B is also incorrect. For option C, it is given to us the relative speed of approach is equal to relative speed of separation for perfectly elastic collision. This statement is correct. Relative speed of approach is equal to relative speed of separation for elastic collisions. And in elastic collisions, kinetic energy initial is also equal to kinetic energy final. So this statement is correct. If you look at option D, it is given to us when two objects of different masses collide, they exert forces of different magnitudes on each other. The force applied on two objects when they collide does not depend on mass of the objects. So different magnitude, they exert same magnitude of force on each other. So the force applied on two objects when they collide with each other does not depend on mass of the object. So option D is also incorrect. So in this video, we have done from question 1 to question 10. I hope you have better understanding of these questions and also you have improved your concepts. If this video was helpful, please like and subscribe the channel because your encouragement is very important. And I'll be uploading videos for remaining questions very soon. And also, if you have any question, just leave your question in comments and I'll explain you as soon as possible. Bye for now. See you in next video.